Alright, so when we did the first 4 sections and we talked about a lot of the trig functions and we did everything dealing with like the unit circle and how the main points were obviously like 0 and then it went to pi over 6 and pi over 2 or pi over 4, excuse me, pi over 6, 3, pi over 2 and just kind of went around the circle. So whenever we have the circle, it just is going to go, obviously, just keep continuing to repeat over and over and over again. Whenever we actually put it in a graph of like sine of x or cosine of x or tangent of x, what you'll start to see is that those same values that continue to repeat, just like they did with the unit circle, they're going to repeat on the graph. Okay? And like I kind of said before to you all before we started, that it basically looks like a roller coaster. Okay? Or just like hills going up and down. Because it's going to be the same thing regardless. Because it's going around that circle, your values aren't going to change. Okay? Depending on like how big your circle would be, then your values obviously change. But for the most part, or for the entire thing, they're just going to continue to repeat for a certain period is what it's called whenever we deal with the graph of y equal to sine of x or cosine of x, things like that. So the table that's here shows the values of your x and your y between 0 and 2 pi. So like whenever we had 0 to 2 pi, that's just a full circle. Because everything after that is just going to repeat those same values again. So just like if we would do the hand trick of sine, remember sine is always, or your x value would be whatever like spot on your hand it is. Your y value of sine is just whatever's on the bottom side. So like if we would just go through everything, you know, if we had, remember whenever we have the hand trick, we have the square root of whatever over 2. We have 0, we have 30, or let's actually put it in. We have pi over 6, we have pi over 4, we have pi over 3, and we have pi over 2. So whenever we go through everything, remember whenever we do pi over 6 and we're here and we bend this finger, we had one finger below, so we would have the square root of 1 over 2, and that's how we got the 1/2 right here. Same way when we went to pi over 3, and we did here, and we did square root of 3 over 2, and that's how we get the square root of 3 over 2. The big ones that we don't use are like whenever we deal with the graph, we can do pi over 4, but it's always going to be the square root of 2 over 2. It's just a matter if it's positive or negative. Okay. If you notice though, then whenever we hit like the 1 or we hit pi over 2 and we hit the thumb, just like we did whenever we had the 0 value, the only thing that's different here is that whenever we fold that under, it's just going to be a 0 up there, but it's still, bottom side, my fault. So we have these 4, and we have the square root of 4 over 2, which is going to be 1. Notice as it goes, what happens to your values as we start to roll through. Like, what do you notice about your values from where we start at 0 to where we go to pi? It's the same values, right? It goes from 0 to 1/2 to the square root of 3 over 2 to 1. Then it goes back down from the square root of 3 over 2 to 1/2 back to 0. It's basically like a parabola. Okay, if you think about it that way. And then with your values on the back side, whenever it goes, and we'll even include the 0 here, it's going to do the same thing, but it's going to go the underneath side. Okay? Just like it did with the circle, you know, whenever we had the unit circle and we went here, everything up here as far as my y value was positive. Then whenever we hit everything past, you know, if here was pi and there was 0, here was pi over 2, here's 3 pi over 2. Everything between 0 and pi for our sine value or our y value was always positive. Everything on the bottom side, once we went from 0, or from pi to 2 pi, everything was negative. It was on the bottom side of that circle. Okay? So whenever we have the graph of sine of x, it's going to look, as far as the original, is going to look like this here. It's basically your circle, and it's all those same points. Okay? The main ones that we're going to work with, and the main ones that we ultimately care about, are going to be at 0, are going to be at pi over 2, are going to be at pi, 3 pi over 2, and then 2 pi. So of those values, those are the values that are key points, because we can actually graph and know exactly where those values are, right? Because those values are at 0, they're at 1, they're at 0 again, they're at -1, and they're at 0. Not to say that we can't graph where, like, we could obviously graph where the square root, where pi over 6 is, because it's 1/2. Realistically, though, do we want to graph 1/2 every single time? Probably not. Okay? We're not really worried about, we're worried about key points and not every single point. Okay? Do you know exactly where the square root of 3 over 2 is? Probably not. Okay? You don't want to worry about where 0.707, you know, whatever it is a decimal, you don't want to have to worry about where that is. So all sine functions are going to look the same. They're all going to have this same curve. Okay, it's going to go up, it's going to hit to 0, and then it's just going to bell its way back around, back to 0. So whenever we do this, your range of, first off, as far as our domain, is this graph ever going to stop moving from left to right? No. So what's my domain? Negative infinity to positive infinity. Now, what's my ceiling and what's my floor of my function? Like, what's the range? What's the y value? As far as the original, what's the y value going to be between? -1 and 1. Both of those values are included. Okay. The period then talks about, whenever we talk about a period of any trig function, we talk about how many times until, or how long until the thing starts to repeat. Well, hopefully it's fairly obvious that it's going to go from 0 here to 2 pi. Because, think about it this way. When do we start drawing over our circle again as we start going around it? From 0 to where? Where do we go back? When do we hit, whenever we draw our circle, okay, if we think about the unit circle that we had, if there's the x-axis, if we start at 0, let's use something that can actually color it. What happens when we get back to 2 pi? what's going to continue to happen as we keep going around this thing? Just going to, every 2 pi, it's just going to keep circling back around. So our period is really just 2 pi in length. And then is it even or odd? It's going to be odd because your values are going to be opposites of each other. If we plug in, if we have a negative version, then it's going to be, if we have a negative value for x, it's going to give you the same value, but a negative or the opposite version of it in terms of our y value. So then, whenever the only thing that's really going to change for right now is whenever we did quadratics, whenever we did cubics and stuff like that, and we had our scale factor. That's the only thing we're really going to worry about right now. We're not going to shift anything left, right, up, or down. We're just going to keep it. We're just going to basically make the hills or the valleys taller or longer. Okay. We're going to do that with what's called the amplitude. That's basically whatever number we're multiplying it by. Okay. Same thing, like if it was negative, then it would flip it over the x-axis. If it's still positive, but say it's like 1/2 or a 2 or a 4, we're just going to take our key values and just multiply it by that number. So, like if the graph over here to the right where it says y equals 2 times sine x. So if sine of x is normally at 0, 0 times 2 is still at 0. If pi over 2, or at that 90-degree mark, is at a positive 1, all we're going to do is just multiply that value by 2. Same way if it's a negative, we're just going to multiply that value by 2. You will get into the habit of, like if it says determine the amplitude of y equals 1/2 sine. Graph y equal to sine of x, and graph y equal to 1/2 sine of x. So you can do this a couple different ways. Your amplitude is just whatever number we're multiplying it by. So in this case, it's going to be 1/2. Now, if it's negative, we'll have to take take the absolute value of it, because your amplitude is always going to be positive. Okay, the negative is just going to flip it over. If you need to, or what I would suggest to start probably here, is to put everything in a table. And whenever I do, use values that are going to be easy to work with. Okay? So if I have x, and I have y, and I have 1/2 y. Okay? All that 1/2 is just going to take my regular values and just multiply it by 1/2. Use values that are easy to graph. So at every change at pi over 2, pi, 3 pi over 2, and 2 pi, those are values that are going to be nice and neat to graph, okay, as far as my original function. I start at 0, it's going to go up to 1, it's going to come back down to 0, it's going to drop all the way to -1, and then it's going to come back to 0. Okay? Until we start to shift anything and move anything, those are going to be your key points. Okay? Because whenever we do pi over 2, okay, it's going to go up to 1. If you have to use or think about your unit circle, then it's going to go with where those values as far as your 1, your -1, and stuff like that. So if we just take whatever we have in that second column, what's 0 times 1/2? 0. What's 1 times 1/2? 1/2. 0 again, negative 1/2, and then 0. So whenever we graph it, again, your easy spots to graph, again, are at 0. They're going to be at pi. So whenever we graph this, the values that you want to essentially start at, again, until we start to shift things left, right, up, down, stuff like that, but for right now, whenever we're just messing with the amplitude, essentially, you have a point at 0, 0, you have a point at pi and 0, you have a point at 2 pi and 0. Because, like we spent the last so much time, where's it at 0? It's at 0, at pi, and then back to 2 pi. Okay, as we go around our circle. Then, where is the value up here at pi over 2? What's our point right there? 1. So, at pi over 2, we're just at 1. Where are we at down here at 3 pi over 2? We're at negative 1. And as you get further into this, okay, you're just going to kind of take it and and it's not going to be perfect. It's going to look something like that. We do the same thing, but now instead of, like, I'm still going to be at 0, 0. I'm still going to be at pi and 0. I'm going to still be at 2 pi and 0. The only ones that are really going to be affected are everything else. So like at pi over 2, at 3 pi over 2. It's just going to be a little bit shorter. It's going to look something like that. Now, again, it's not going to be perfect. I'm not so much worried about how much your graph looks like, as long as, as long as you do 1/2 of sine, you're like, woo! Like that, you're in good shape. Be a little bit under control and make a little common sense out of it and go from there. But all we're doing here is just taking our original and just kind of stretching it out and pulling it at its main points. So like on the second one, where we have amplitude of 3, or find the amplitude of y equals 3 times sine of x. So again, as far as our originals are concerned, our originals are at 0, 0. Our original is at pi over 2 and 1. 0 and pi and 0. 3 pi over 2 and negative 1. So if my originals are here and look something like this, what's 3 times sine of x going to look like? Like, did the 0 change down here? No. Did the 0 change at pi? Nope. Did the 0 change at 2 pi? No. Where's the main points that it changed? Pi over 2, 3 pi over 2, okay, and then all I'm doing is just taking it, just a little bit more fun of a roller coaster to ride. Again, if you need to put it in a table, that's fine. Do that for right now. But these values, as far as kind of like our reference points, they're not changing right now. They will over time and as we get further into it, but for right now, they're not going to change. Same way if nothing's going to change from the start. we're still going to have a point at 0, 0. We're still going to have a point, as far as my original at pi over 2 and 1. We're still going to have a reference point of pi and 0, and then just continue to go on. Okay? The only thing, or the main thing that's going to change here is that if we have if here's pi, there's 2 pi, and there's 3 pi. Pi over 2. As far as my originals are concerned, 1, 3, if we just go 3, I'm going to have a point here at 0. I'm going to have another point at 0 and 0. Where's my next 0 point? Because it goes, so it says for a period from 0 to 3 pi. So instead of just going to 2 pi, I'm going to 3 pi. What does it do every half unit? It goes back to 0, right? So I'm going to have a point here. I'm going to have a point there. And it's going to look something similar. And it would just keep going. Even if I just, there we go. Every 2 pi, we're going to section one off, and it's going to be the same looking thing. Now, if it's a -2, how's that going to affect like the red one? How's that going to change it? My amplitude, or my A, is at 2 or -2, but what's my actual amplitude? What's the absolute value of -2? Just 2. Okay, my amplitude always has to be positive. Okay, that can't change. But only thing it's going to do is just change my graph, and I'm still going to be at 0 at every single spot. But now, instead of being up at +1, I'm going to be down at -2. Instead of being at -1, I'm going to be up at +2. It's just going to be flipped as far as how everything looks. And then my amplitude is just going to be a little bit higher. Now, the only thing different between sine and cosine, they look the exact same, but instead of starting at 0 and maxing out at 1 and then bottoming out at -1, with cosine you're going to start at 1 and then really it's just going to look like a valley and then coming out of it. Okay? Whereas sine starts at kind of the equator, or whatever you want to call it. It jumps up and then it comes back down and then comes back up to the surface again. Whereas whenever we have cosine, we're starting up above or at the top, we're diving all the way down and then coming back through. Okay, it's really just shifted over. Okay, the difference between sine and cosine is that cosine is shifted what we would call like pi over 2 one way, or it's really shifted to the left pi over 2 spaces. Okay? If you notice that normally sine would start right here and it would end here, whereas with cosine we start here at 1 and then we end at 1, and it's everything in between. The graphs aren't any different, it's just how it's shifted. Okay, it's just shifted basically pi over 2 units to the left. So then your last example, if we're at cosine, cosine normally is going to start at a positive 1, and then it's going to end at a positive 1. It's going to look something really like a parabola, like this here. Now I missed my mark at 3 pi over 2, but you kind of get the idea. If we're going to multiply everything by -4, so a is -4, that means that my amplitude is really at positive 4. So then it's just going to mirror, but it's just going to take each value and multiply it by -4. It's going to look the same. It's going to be odd because those values are but it's really just going to look like a parabola is all it is. Okay? We're just taking those values, we multiplied that one by -4, we multiplied this one by -4, same way.